Dear students, welcome to CR's digital classes. Today, let us learn the concept of randomized and non-randomized test. So, what are these randomized or non-randomized tests? Let us know today. So, first, randomized test function. Let us learn. So, randomized word we know already. Random variables will call from SEM 1. We'll come to know this word. So, what is the random variable? Random variable is randomly we'll pick a variable to sort our probabilities or so to sort our distributions to get our data. So whenever we represent some data randomly through a variable, we'll call as random variable, right? In the same way here, randomized test function we have. Randomly we'll pick a function, we'll try to represent our probabilities through that distribution is your randomized test function. Let us learn how it goes on through the definition. So a function psi of dot, a function because that function we are taking by our own, so just notation we are considering just like theta, so like that psi I am considering as my representation for the function. So psi of dot means sum of the function, maybe some distribution, some population I am considering here as a function for me. So I am taking psi of dot is said to be randomized test function if its sample space values lie in the close interval 0 comma 1. So here my function I am considering a function where the interval will be close interval and the values in between 0 to 1 if you consider, that is your randomized test function. Now how it goes on? Close set means close interval means the value should be in between. So 0 to 1 is the values I am considering here as my limits. So how it goes on? 0 less than or equal to psi of x less than or equal to 1. So close interval means in between 0 to 1 we can get the values. The same as probability, right? Probability also lies between 0 to 1. The same thing here, we'll call it as random test function because some function we are considering here and we are trying to give the same probabilities as the limits for us. So 0 to 1 if it is false in that particular, we call it as randomized test function for all x. Then the expectation and rejection of null hypothesis H naught is decided with the probability psi of x and 1 minus psi of x. So here we'll consider expectations as well as we'll try to reject the null hypothesis. So if for null hypothesis is rejected, we'll get as 1 minus psi of x. So this is how it goes on in this function. So in case that value of the random variable x is equal to the observed value of x, then two possible outcomes, say p and are considered with the above probabilities. So whenever we'll have conditions like this, so what we do is observed values we'll try to compare with the expected values, means observed values means given data, and we'll try to sort the data using some distributions, right? And we'll get some answers we'll call as expected data over there, expected values. So whenever we'll get equal values, two possibilities will get over there. So then our hypothesis H naught is rejected if P occurs in the experiment, otherwise H naught is accepted. So H naught is rejected if P occurs. So when P is outcome, we call random variable x is equal to the observed value. So random variable whatever we have considered, we have taken expectation, and if it is equal to the observed frequencies, observed values, then we'll call it as P, and we'll take the null hypothesis as a rejected. So we'll always in this unit we'll always try to check how null alternative hypothesis goes on. So whether to accept the data or reject the data, we'll try to know here. So through null hypothesis we do that, right? So if you reject the null hypothesis, that is it goes to the outcomes values will be equal, observed values and expected values will be equal, so that H naught is rejected. Otherwise we'll accept our H naught. So here psi of x is called a critical function. An example of randomized test function here, just as an example, they have derived some values. Check it out. Psi of x is equal to 1 if x is equal to 3 and 1 by 8 x is equal to 2, 0. Otherwise, just an example they have derived here. So check it out. Always probabilities we got as 1, 1 by 8 is 0. So this is how the randomized test function will go on. So randomized test function is nothing but we'll assume some function here. That function should lie in between 0 to 1. The probabilities will be 0 to 1, and observed values, if it is equal to expected values, will reject a null hypothesis, and otherwise will accept null hypothesis. That's what is your randomized test function all about. Now let us check it out. Non-randomized test function. So now how non-randomized function will go on, let us check it out. A function is said to be non-randomized test function if all the sample values lie in the open interval 0 to 1. So again interval is 0 to 1, but it is an open interval. Now what is open interval? Let us learn. Either 0 or 1. So directly we'll get the answers as either 0 or 1. So that is what we call as the open interval. So just like randomized, non-randomized also is a function, we'll consider that function should be an of open interval and the limits are 0 and 1. Means either we'll get 0 the probability or 1 as the probability. So now let us check it out how it goes on through the null hypothesis, whether we need to reject null hypothesis or accept null hypothesis based on this open interval. Let us check it out that also. So when null hypothesis H0 is rejected, the sample space is divided into two sets, say Q and the complement of Q. So again here we'll divide the Q, we'll consider some Q and we'll divide that into two again. One for H0 is rejected, that is Q. If it is accepted, complementary of Q, that is your Q dash also will write, right? So Q dash is complementary. So two types will represent here. Rejecting Q, accepting is Q dash, complementary of Q, in such a way that Q union Q dash is sample space. Yes, obviously both together will consider, it goes to the sample space, all the outcomes together will represent in sample space. So Q union Q dash becomes our sample space, and the Q intersection Q dash is a null set. Means Q intersection Q dash will not exist at all. Q is complementary for Q dash or Q dash is complementary for Q. Obviously it goes to the null set. Here Q is called rejection region because H0 is rejected. Yes, whenever we reject H0, that comes under critical region, that falls under critical region. We have learned under critical region definition. So obviously Q is called critical region, rejection region or critical region when H0 is rejected. So a non-randomized test function can be written as, so they have given here how it is represented. Phi of x is equal to 0 and 1. 0 or 1 will be your representation. So this is your non-randomized test function. So this is very important. Most of the time it is covered from first unit. So check it out, randomized and non-randomized test functions. So hope you have understood this particular session. See you all in the next session. Thank you.